Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called XV star dash 0 dash star 4, and it's by Nurgle's Gift, and this is using his XV and connected X lines situations. I've been doing a decent amount of these because I find them enjoyable, so that's the only reason why I'm doing them. But they're very fun for me, so I hope you have fun too at the same time, following it or solving it for yourself. Anyways, here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or box. Cells connected by a black dot must be in a 1 to 2 ratio, otherwise known as black crop key dots. So if this were 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them. Cells connected by an X must sum to 10. So if this were a 3, this would have to be 7 because these two digits sum to 10. Cells connected by a V must sum to 5. So if this were 3, this would have to be a 2 because these two digits must add up to 5. And all X's and V's are given. So this is very typical of Nurgle's Gift's XV puzzles, where basically the negative constraint is in place. So because we know all X's and V's are given, there cannot, if this were, say, a 3, you could not have a 2 or a 7. Well, we would celebrate because 3 is in the corner. But we would know there's no 2 and 7 in a cell that is adjacent to it, or shares an edge with it, shall we say. Because there's no V there and there's no X there. And we know all the X's and V's are already given. So that's the negative constraint there. Two lines of the same length and same color are connected X lines. Counting from the bulb, the first cell of each connected X line sums to 10. The second cell of each line sums to 10, etc., etc. 5 can never be on a line. So, as an example, take a look at this line here. This is of line length 2, and it's orange. Match it with the other one. So if this were, say, a 2, this would have to be an 8 to add up to 10, because you start from the bulb of the same length line and same color line, and the first digits in the bulb must add up to 10. The second digits must also add up to 10. So say this was 3, this would have to be a 7, because these two digits must add up to 10 also. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, well, we have a certain amount of V's. So, let's mark all of those with the digits 1 through 4. Right? These are 1 through 4. That means here the fourth digit must be a matching 6 through 9. The fourth digit on the orange line must be a matching 6 through 9. We're going to mark this as green. This is red. This is orange, or pink and orange. Well, what is this low digit? It must be the red, because that's the only color remaining. So this must be green because it adds up with the red to add up to 5. These are pink and orange, but we're not sure which one's which. Therefore, this one matches here. So it's the pink 6 through 9. This cannot be 1 through 4 because we have a 1, 2, 3, 4 quadruplet in box 4. So this must be a 6 through 9 because it can't be a 5. It must match with this digit, I think, right? Yes, it matches with this one. So this is 1 through 4. Um, we don't know which one this is. It cannot be orange, so this must be then green or red. So this is green or red, 6 through 9. This is a 6 through 9. Oops. And it matches with a 1 through 4 here. So this is 1 through 4, this is 6 through 9. This is orange or pink. This 1 through 4 cannot be pink. It could be red or green. But if it's red, this would then be red, and therefore this would have to have that X in between them. So it can't be red. It could be green or orange here. So this is green or orange. We're not sure which. Orange or pink, orange or pink. This cannot be, okay. This is also a 6 through 9 here. Because we have a 1, 2, 3, 4 quadruplet in the box 6. These are also 6 through 9, but you also could have a 5 because we have 1, 2, 3, 4 triplet. These are 5 through 9. This is 5 through 9 also. This 6 through 9 means this has to be 1 through 4. It cannot be the pink one. It can't be the orange one. It's red or green here. So this is red or green. This then must be red or green, 6 through 9. Right? It can't be orange. It can't be pink because if it were pink, it would be next to, it would have to have an X in between this. And it can't be orange. This then cannot be red and green because this has to be a red or green low. And if this is red and green, it would eliminate all possibilities for that cell. So this is pink and orange here, which makes this red and green here. Okay. That means this pair of digits cannot be pink or orange because that would eliminate all possibilities for that cell there. So this must be red and green here. Well, where are the red and green lows in column 5? Can't be here. Can't be here. Can't be here. It must be these two cells. So this must be a low, and it's green because it can't be the red one. This must be the red low. Where are the orange and pink lows in row 4? Can't be here, can't be here, can't be any of these. It has to be one of these two, right? So this is a low, pink or orange. This is a low, pink or, oops. A low, pink or orange. Well, what does that mean? This is a low green, so this must be here a high green to match it, to add up to 10 with it. Therefore, this cannot be the low green. It has to be the low red, which forces this not to be the low red. So that's a low green. This can't be low red, so this is low green. This can't be low green, so this is low red here. This low red then matches with this, which means it's a high red here. This can't be the high red then. It's a low green, which means this. Wait. This has to be, okay, well, we already matched that, so that's fine. This cannot be a low because we have 1, 2, 3, 4 quadruplet in the column. This is 5 through 9. This has to be 6 through 9, and these are 5 through 9 here, 5 through 9 here. This 6 through 9 would force this to be a 1 through 4. Cannot be green, cannot be red, cannot be orange. This must be pink. So this is pink, which means this is a pink high. This cannot be a low because it sees all 4 lows. This must be a high then here, which means this has to be a low, which means this is a high here. And these two match. Obviously it can't be pink, red, or green highs because then you would have an X next to all of them. Therefore, this must be an orange high, which means this is an orange low here, which means this is an orange high. Okay. Hmm. Hmm. This can't be green high because we already have a green high in the box, so this must be orange high, which means this must be orange low here. Orange high, orange low. This cannot be orange then, because there would be an X between them. So this must be pink, which means this can't be pink, this is orange. This can't be pink, this has to be the high orange. Okay. Hmm. Where is the high green in box 2? Can't be here. It can't be either of these two because there would then be an X in between this and the green low. So it must be here. So this is the green high here. Where's the green high here? Hmm. Hmm. Where is the red high? In box 2. Actually, so this cannot be red high here. What can this be, actually? One of these is 5. So one of these is a 5, which means this can't be 5 here. This is a 6 through 9. One of these is a 5. One of these is a high red, which cannot be here. Therefore, the other one must be the low. And it's a low orange. So this is a low orange, which forces this to be the high orange. Okay. And one of these is the high red here. We're not sure which. So this is 5 through 9, 5 through 9. We have a low pink here somewhere. We're not sure which. Oh, the low pink cannot be next to the low orange because they add up to 5. And this would then have a V behind it. So this must be the low pink. Where can the orange, high orange be? It has to be one of these two cells here because it cannot be here because of this one, can't be here because of this one. So it's one of those two, which means the high orange, where's the high orange in column 1? Can't be here because of this one, can't be any of these, can't be here or here. This must be the high orange. Where is the low orange then? Low orange cannot be here, cannot be here, cannot be here or here. It must be here. So this is low orange. Low red has to be one of these two. We don't know what else though. Where is high red? Actually, we already know that. High red has to be one of these two here. High red also has to be one of these two here. So this is, okay, so this is a 6, 7, 8, 9. It cannot be pink. Where is the pink then? High. Can't be pink because this would have an X between them. Therefore, this is the pink high because that's the only place for it. Can't be here because of that pink high. And these are no longer available. This has to be actually the red high here. So the remaining one is a green high. So this is green high here. Which means where is the green high in box 4? It has to be here. So this is a green high. We know one of these is a 5 and must be the red. Okay, can't be red 5. It must be the orange 5 here. But we're not sure which one. We have a 5 here. This must be then, we have a 1, 2, 3, 4. And we have a 6, 7, 8, 9. But if this were a 1, 2, 3, 4, actually it could be either 1, 2, 3, 4. Where is the orange 1, 2, 3, 4 here? It has to be one of these cells, which is a 1 to 2 ratio. Hmm. Where is the green low in row 3? Can't be any of these because of the low green in those boxes. Can't be here. It must be here. So this is a low green here. So this is a combination of we need a high green to be one of these two cells. This cannot be high green because of that high green. So this must be the high green. We have all the orange. So we need a low here, which means this is the low red. And one of these is the high red. We're not sure which. This is 5 through 9. I'm not sure which. These. We need a pink. We need both pinks, right? We also need a high red. Okay. This is 5 through 9 here. You can never have a 1 to 2 ratio between two digits that add up to 5, right? Because one has to be odd and the other has to be even. And the only odd even pair that would work would be 1 and 2, but that doesn't add up to 5. I guess you could have 3 and 6, but that also doesn't add up to 5. Therefore, this must be the low 1, 2, 3, 4. And the pink one has to be here then. So, since this is it cannot be low and low, this has to be low with high. So this must be 3, 4, and 6, and 8. We don't know what the other one is here. Therefore, this is 1 or 2 here. So the orange has to be 3 or 4, which means it matches with 6 or 7. This is 6 or 7. This is 6 or 7. 3, 4. This is 3, 4. 6 or 7. 3, 4. This is 1 or 2. 3, 4. 6, 7, which makes this. It's pink, right? Yeah. 1, 2 with 8 and 9. This is 8 and 9. Okay. This must be the same, right? This must be the same digit here. One of these is, so we have a high. This must be a high then. Oh, it doesn't have to be. It could actually be a low here. We just don't know. What are the remaining digits here? We have a low pink, which cannot be here, but it could be here and it could be here, unfortunately. Actually, this is 5 through 9 also. It can be 5 or it can be orange. Well, the orange high cannot be here. Where can the orange high be in row 4? It has to be here. So it cannot be a 5. This is the high orange, which makes this 8 or 6 or 7 here. Therefore, the high orange must be one of these two cells, and it must be this one specifically, because this one is a high orange. Well, high orange in box 2 cannot be here or here, and it can't be here. Can't be that digit, so this must be the high orange left. This is 8 or 9. Sorry, 6 or 7, not 8 or 9. This is then a 5, because that's the only digit remaining. This can't be a 5. It must be a high digit. It can't be high orange, red, or green, so this is high pink. So this is 8 or 9. High pink cannot be here. High pink cannot be here. It can only be there then. This must be high pink also. High pink is one of these two. Actually, this can't be high pink because this is high pink. Therefore, this must be high pink here. Which leaves that as the only remaining high pink. We have what? High red left here. Okay. Where's the high red in column? It could be either of these, right? These are still kind of up in the air. We have a 5 here, and then we have what? Green, high green, and high red. Well, high green and high red cannot be here, so this must be then a 5. So one of these is high green, the other one's high red. This can't be high green. This has to be then high red, which makes this high green, because that's a high green here. We only have one place left for the 5 here. It has to be here in column 6, right? Everything else is taken. These cannot be 5. This is the only place, so this cannot be 5 here, which means we need a 5 in one of these columns, in column 4. Cannot be here, cannot be here, can't be here, because that would have to be in a 1 to 2 ratio, and 5 is not in a 1 to 2 ratio with another digit, so this must be a 5, which makes this the 1, 2, and it's the pink. This can no longer be orange, because this is not pink low. This is not orange low. So this is 3 or 4. This is 1 or 2 here. This can't be the low orange, so this must be the low orange here. And the remaining digits here are, we have a high green and a high red, but this cannot be high green, because if this were high green, it would match, this would be an X in there. Therefore, this must be a high red. This must be then a high green. So all the high greens are 6 or 8. Because of that, we know the low greens are 2 and 4, which makes the reds 1 and 3. Therefore, the high reds are 7 and 9. Okay. Therefore, this digit is in a 1 to, this orange low is in a 1 to 2 ratio with 2 unique digits. So it cannot be 4, it has to be 3. This can't be an orange low. So this is a pink low. This can't be a pink low. This is an orange. So this is 1 or 2. This is 3 or 4. So all the oranges are 4, which makes all the greens high to be 8. This then must be the green low and is a 2, which works. So the pink lows are 1s. So these are 1, which forces the 8 and 9 pinks. Okay, well, let's get the 1. Okay, so this cannot be 1 or 4. This is 2 and 3. This cannot be the green then, because this would have to have an X between them. This would not be green. This would be green. So let's get all the 8s and remove those colorings. Let's remove the colorings from the 4s. And we can remove the colorings from the 1s. So all the pinks now are 9s. All the high oranges are 6. All the low greens are 2. All the reds, well, those are 3. And this is a 3. We can remove all the coloring for the 3s. So all the highs, reds, are 7s now. This cannot be 6 or 9. 6, 8, or 9. This is a 5, 7 pair. This can't be 6, 7, 8. This can't be 6, 8, or 9, so this is 7. This has to be then a 5, which means this is the 7 there. The last remaining digit in column 2 is a 7. We have 3 digits in column 3. That must be 3, 5, or 9. But this can't be 9, this can't be 5, and this can't be 3. We have 3 remaining digits in column 7. Actually, let's go row 2. That's 1, 5, and 7. This can't be 1, so now we have a 5, 7 pair here. Remaining digits in column row 7 are 3, 5, and 8, but this can't be 8 because of that 8, so this must be an 8 here. This is 3 or 5, but because of the 5, 7 pair, we eliminate 5 from the rest of the column. So this is 3, which makes that 5, which makes this 9, which makes that a 3. Remaining digits in row 9 are 7 and 9. This can't be 9 because of this set 9. So this is 7, this is 9. Remaining digits in row 9 are 1, 2, and 5. The 2 has to be here. This is 1 or 5. What else do we have? This is 5 or 7. This can't be 7 here. It can't be 1 here because it would be next to a 9, and therefore it would have to have X there. Therefore, this is 5, this is 7, this is 5, this is 7. This 5 and 7 eliminate that 5 and 7, so that's a 1, which makes that a 5, which makes this a 1. I didn't do the full coloring. I probably should have. It probably would have made this part a lot easier. That's the whole reason for coloring, really, is to make it easier. But once I figured out what these were, I just wanted to go with that. But that probably was not the right choice, I would say. Anyways, as always, very fun with these connected X lines here. And I hope you had a fun time watching this solve, and I'll see you next time on Frank Puzzles. Take care.